Hi, fourth grade. Mrs. Hinterliter here, bringing you another math mini lesson for Chapter 12, Lesson 9 on elapsed time. Today I have 3 elapsed time word problems that you're going to help me work through. All right, let's get started. To begin, we have Bill. Bill wants to be at school at 8:05 a.m. It takes him 20 minutes to walk to school. At what time should he leave his house? So looking at this problem, I know that my time of 8:05 is important. That's the time he wants to be at school, okay? I also know that it takes him 20 minutes to walk to school. That's also important information because that's how long it's going to take for him to get there. And my question asks, at what time should he leave his house? That is also important information for this problem. Okay, so let's take a look. I have a start box, an elapsed timeline, and an end box. So this important information that I located in the problem, I want to do my best to fill out my start box, my elapsed time, and my end box. Well, I'm going to tell you the problems that we're working with, one of these areas are missing, and we need to figure out which one it is. So let's take a look at the information that we have and see where it can go. So the first thing I have is 8:05 a.m. That's where he wants to be at the end of his walk. So for the end box, I'm going to put 8:05 a.m. He wants to be at school at 8:05 a.m. Now, it takes 20 minutes for him to get there. So I know that whenever he leaves his house, it's going to take 20 minutes for him to get there. So on the elapsed timeline, I'm going to put 20 minutes. Okay? And now the question asks, at what time should he leave his house? Well, that would be our start time. That we need to find out. We don't know yet. Okay? So now that I have my end time, my elapsed time, and I know that I'm missing my start time, I can fill out a T-chart below to help me figure out when he should leave his house. So I'll just scoot this down a little bit, okay? On this side, I always work with the hours, and on this side, I always work with the minutes. Just as a reminder, okay? And I also want to put my end time over here of 8:05. That's my end time. Now, I know that it doesn't take him any hours. He doesn't have to walk for hours to get to school. So I'm only going to be working with minutes. But still, I'm going to keep track of the time in hours over here. Now, let me show you what that means, okay? I need to go from 8:05 to a mystery destination, and I'm working backwards, okay? So the first thing I'm going to do is I'm going to take my end time of 8:05, and I'm going to take 5 minutes away. If I take 5 minutes away from 8:05, I now have the hour of 8 o'clock, okay? Now, I took 5 minutes away from 8:05, and I took 5 minutes away from his elapsed time. So now I have 15 minutes left. So if I take away another 15 minutes, this over here equals 20 minutes. And that's the amount that he walked. 15 and 5 is 20. That's the total that he walked, okay? Now, I took the 5 minutes off 8:05 to get 8 o'clock. If I take 15 minutes off of 8 o'clock, I would get 7:45. The reason it's 7 is because I'm going back in time. I actually had an end time. I didn't have a start time. So this is where I ended. If I take 20 minutes away from 8:05, I end with my start time of 7:45 a.m. Okay, let's take a look at another example of elapsed time. So for this one, It's my math class. We're going to be working with my math class. It says Mrs. Hinterliter's math class lasts 40 minutes. Math class starts at 9:55 a.m. What time will it end? So again, let's identify the important information in this problem. First thing I have, Mrs. Hinterliter's math class lasts 40 minutes. That's how long it's going to be, 40 minutes. Math class starts at, 9:55, and it gave us a keyword, starts. So 9:55 is going to be my start time. 9:55 a.m. is going to be my start time. What time will it end? Well, that's the question. What time will it end? That means I have to put a question mark in the end box because we don't know yet. That means the 40 minutes, that's the time that is going to elapse. So let's take a look. When you come into the classroom, math is going to start at 9:55 a.m. You're going to participate in math class for 40 minutes, and then the bell will ring, or you'll transition to your next class at what time? That's what we need to find out. So let's use our T-chart to figure it out. Again, I have my hours and my minutes, and I know now I'm starting with 9:55, so I'm going to put that right here. Okay, I have my start time of 9:55. Well, I know I can easily add 5 minutes to 9:55. If I add 5 minutes to 9:55, I'm at 10 o'clock. I added 5 minutes to get 10 o'clock. Okay. Now remember, this side has to equal 40 minutes because that's how long the elapsed time is. Excuse me. That's how long the elapsed time is. So this number has to add up to get this over here. Okay. So I have 5 minutes. Well, can I add another 5 minutes? Sure. If I add another 5 minutes to 10 o'clock, I now have 10:05. All right. So far, I've used 10 minutes out of my 40. Well, I think everyone can do 40 minus 10 and get 30. So I'm going to add 30 minutes. Now, before I add 30 minutes, I want to check my work over here. 30 plus 5 is 35. 35 plus 5 is 40 minutes. So I know I have my total. Great. Now, in order to get my answer, which is going to go right here in this box, I need to add the current time of 10:05 plus the 30 minutes. 10:05 plus 30 minutes gives me an end time of 10:35 a.m. My start time was 9:55. I participated in math for 40 minutes, and I finished math class at 10:35 a.m. Great job. Thanks for staying with me. Let's do one more together. This one might be a little more challenging because we're working with hours in this one as well. So let's take a look at Jenna. Jenna rode her bike for 1 hour and 15 minutes. She got a flat tire at 2:30 p.m. What time did she start riding her bike? Well, let's find our important information. Jenna rode her bike for 1 hour and 15 minutes. Ooh, that is important. That's how long she's going to be riding her bike for. But unfortunately, she got a flat tire at 2:30 p.m. and couldn't ride anymore. So I need to ask myself, is 2:30 p.m. the time she started riding, or is 2:30 p.m. the time she ended riding? Well, I don't know how much more riding you can do after a flat tire. So 2:30 p.m. is my end time. And then my question, what time did she start riding her bike? So my start is a question mark. I don't know what time she started, but I know when she ended, and I know how long she rode for. 1 hour and 15 minutes. So in order to go from the start to the end, it was 1 hour and 15 minutes. Okay, now using what we know, we need to find out the start time. So I'll put my 2:30 over here so we know the end time. Okay, now the first thing I want to do is I want to take 2:30 and I want to take an hour away from it. If I take 1 hour away from 2:30, I get 1:30 because I'm going backwards in time, remember? So 2:30 minus an hour would be 1:30 in the afternoon. Okay, so that's my hour gone, but she also rode for an additional 15 minutes. So I'm going to take my 1:30 and I'm going to take away 15 minutes. So I'm thinking to myself, 30 minus the 15 minutes that she was still riding would be what time? You guessed it, 1:15. Now over here, we have the total of 1 hour and 15 minutes. We know she ended at 2:30 when her bike got a flat tire. She rode for 1 hour and 15 minutes, which matches this. So what time did she start riding her bike in the afternoon? It would be 1:15 p.m. Now, let's quickly check our work to make sure we got it right. If I knew the start time was 1:15 and I knew she rode for 1 hour and 15 minutes, let's check to make sure 2:30 would be our end time. 1:15 plus 15 minutes would give me 1:30. 1:30 plus 1 hour would give me an end time of 2:30. So, ladies and gentlemen, thank you for joining me today with elapsed time. If using the T-chart is the best way for you to get that answer, then go right ahead. I like it the best. Enjoy your week, and I will see you virtually again soon.